All right, good morning, everybody. Online, can you hear me? Can you see the screen? Turn off that light for me, please. Turn off that switch. Students online, can you hear me? Can you see the screen? Nobody's answering. I guess I can't hear me. Dijon Bedward.
Okay. Yes, sir, we can hear you.
Is it?
All right, cool. All right, so today we're going to be doing this paper, January 2022. This was the first of two mock exam papers yesterday. Tomorrow we'll do the June 2022. Remember, the pass mark on this paper is 70%. It's the business end of the program we're at now. 70%. So if you're not hitting 70%, it means that you have some work to do. You get me? Because this is 2022. The exam that you're actually gonna get is of this standard, of this level. Same 10 questions, same kind of structure. So the exam that you're gonna get is a good reflection of that exam. So need to be hitting at least 70% now. Next week we're gonna move it again. 85%. So we're making big leaps now. Because we're doing marathons now, we're doing a lot of extra work now. They're supposed to be making leaps. Not no mini improvement anymore. You need to be making big improvements now. If you're serious, that's why you need to come in the class and stop giggle. And start meds the maths and stop joke out the thing. Serious business time now. Otherwise, you're going to cry when the exam done. All the giggling now when turn to crying when the exam done. If you don't get serious. You have to get serious at some point. Once you don't come class, you're supposed to have one focus. Meds the maths. Everything you're supposed to have just zone in and doing the work. And stop just fooling around. You come here for one purpose only. No. Not to cavort. It's not about cavorting now. Understand? I plan to have some additional revision sessions. And I want to actually do it off base, away from here. So I'm trying to make that arrangement. And I feel as if to say, I'm gonna have some tickets and give tickets to persons who are not serious to attend that session, those sessions. So we know we have a room of people who are serious and I come there on a joking thing. Just give persons tickets, and if you don't have a ticket, they can't come. Stay and you join online. And we provide refreshments and everything. That is my plan. But some of you guys, don't give me no motivation to go that route. Because you're not coming in a joking thing. Yesterday we were doing the session and some people inside just laugh. Like, I don't understand. I'm supposed to be serious and I put in some work now and I laugh, joke. And the problem is that some of you are not ready. Who are laugh, skin, green. You're not ready. So you know how to find time to be laughing and skinning and grinning. In a session, we're supposed to be meds in the maths and having a focus and trying to cement everything. Tell people all the time, when you learn something, two things can happen to whatever you learn. Two things can happen to whatever you learn. Either you retain what you learn or you forget what you learn. Two things happen to anything you learn, Either you retain it or you forget it. You have to do the things that will assist you to retain it. If you learn something and you just understand something and then you're gone off and start talk about the match, Chelsea versus Liverpool, and you start change your focus and start talk about other things, and you don't give yourself a chance for what you learn to cement in your cerebral cortex, in your memory bank, then it means that you are accelerating the process of forgetting what you have learned. That is why a lot of you will understand something this moment and forget it within 15, 20 minutes because you're gone up and talk about something else. You know, focus on meds it a little bit, make it stick in your memory. You know, give it no time to stick and stay in your brain. And that is why some of the things you have to see it 100 times. You sometimes I give you a question, you know, and I give you about the same question. And a lot of you, it's like it's strange to you, like you have never seen it before. It is ridiculous. It tells me that you're not serious. Some of you make a mistake today and make the same mistake again tomorrow. That is what sets some people apart from others. Because some people say, look, I make that mistake here. Let me focus on this mistake. Let me meds it. Let me look at it and say, how I make that mistake here? What is the right thing? And them cement it in them head. They're not making that mistake again. That is how you improve. That is how you move forward. But you guys, you present catalysts, the catalyst for you to forget stuff by talking about other things. You don't give yourself no time to cement what you have learned. Make work hard for a teacher like me when you don't have to be so hard. I shouldn't have to be telling you the same thing 100 times if you're serious. But you are too easily distracted. If you don't know how to do it that way there before, you need to start doing it now. Because as I say, you need to be improving at a rapid rate between now and the exam if you want to gain success in the exam. So now it's time for you to meds the maths. When I say meds it, I mean when you learn something, and say, okay, I understand this now, you focus on it for a bit. Give it some time to cement in your brain. Just as if you get a telephone number and you want to make sure so you remember the telephone number. Where do you look for the number good? Like you force it in your memory. Some of you don't do that to the maths. You need to be doing that to the maths as well. Force it in your memory. You get me? Anyway, let's continue. And let us start. Come on, have to do the right things to facilitate proper learning, man. Don't talk too much. Not too easily distracted. You don't give yourself the chance or the time to retain what you learn. Forgetting too much. Students come to me, sir, I don't remember this, I forget it. You have not given yourself the opportunity to retain it. That's why you're gonna forget it. All right, let's go. So this is January 2022 paper. And the first question, as usual, start out asking you to use a calculator to work that thing out. And so we're just going to use a calculator, as it said, and work it out. And all you have to do is ensure that we type it in the calculator exactly as it appears on paper right here. That is a challenge. And so you'll benefit from doing that by getting one of those calculators that you can write this in exactly as it appears there. So the fraction 8.9 plus, what is that? 31.6. That goes over 0.75 times 5.4. That works out to be 10. Look at it, make sure it's the same thing. Looks like that to me. That is equal to 10. Simple as that. All right. Next question. They want us to work this out and give the answer to one decimal place. Same thing, calculator again. This expression. So it's 3.9 times the tan of 18. Make sure the calculator is in degrees. If you look up there, you're going to say DEG at the top. If you're not seeing that on the calculator, it's not in degrees. If it's in any other mode, like radians, you're not going to get the correct answer. Calculator must be in degrees. So that tells me it is 3.9 times tan of 18, 1.2 something. Let me write out the whole thing first. I'm getting 1.267 and so on. I want to correct to 1 decimal place. 1 decimal place is here. 1 digit after the decimal point. You're going to use this 6 to correct it. Because this is greater than 5. It increases this by 1. And so then it simply becomes 1.3 to 1 decimal place. Simple as that. Next question. Next question here is a consumer arithmetic question. Payroll. It says Rhea is paid at a rate of $13.50 per hour. That's her regular pay. She gets $13.50 every hour. It says during a certain week, she works 40 hours. How much did she earn in that week? 40 times this. Because she's paid this amount for every hour and she's working this number of hours. So she gets 40 hours times the hourly rate of $13.50. That is all. That is the amount that she gets in a week. So it's 40 times 13.5. $540. You have to put the dollar sign. She gets $540, and this is per week. In that 40-hour week, right? So let's write that as per week or for that week. All right, for that week. But I think this is how much she's going to earn per week anyway. Next part says, Rhea worked 4 weeks. So as regular pay, she's getting 4 times that. 4 weeks. In the month of August. And her gross pay, the gross pay is the pay that she gets before any deduction is taken. That's what we mean by the gross pay. The amount that she gets before they start to deduct taxes and insurance and any other deduction. It says a regular week comprises of 40 hours. Or a regular week comprises of 40 hours. It means then that this is our regular weekly pay. We calculated that on the 40 hours. All right. This is the per week rate. And overtime is paid at 1.5, the hourly rate. So it means that time and overtime is 1.5 times this $13.50. That's the overtime rate. So we can literally write it here. You can put it here. So the overtime rate. So this is a regular rate per hour. The overtime rate, we can just calculate it right here. They don't ask us for it. We can just calculate it right here. We can call it the OT rate. That's the OT rate per hour. Per OT hour. OT means overtime. So every overtime hour, she's going to get 1.5 times $13.50. That's how much she is getting for every hour of overtime that she does. Let's work it out. So this works out to be 1.5, which is the same as 1.5 times 13.5. So she's paid $20.25 for every overtime hour that she does. So that is per overtime hour. $20.25. All right, let's change this color because it's not a part of a thing. This is just additional information we're picking out. All right, so this is the amount that she gets for overtime every hour. It says, this is her gross pay. Show that she worked 15 hours overtime. 15 hours overtime. So that's if we want to calculate the overtime and show that it is 15. That's one way to do it. Another way to do it is to use the 15 hours overtime and show that the gross pay is this. I'm going to do it the way where we calculate the overtime hours and show that it is 15. So the first thing we need to know is how much money overtime she gets. Out of this amount of money, how much of it is overtime? So remember that it is 4 weeks work normally, and each week is 540. So we can calculate the overtime pay. Let's write it like this. The overtime pay is equal to the total that you got, which was 2463.75, subtract 4 times the regular weekly pay, because it's 4 of this in the 4 weeks. 4 times 540. So the overtime pay is whatever this works out to be. Let's just work it out. I don't have to do it this way with so much calculation, but I just want to ensure that you understand it. So it's 2,463.75 minus 4 times 540. So she gets this amount in overtime pay. 303.75. This is the amount that she gets in total overtime pay, working at this overtime rate. Yes? Or you get what? Huh? Which one? What? What is what? What? Overtime rate? All right. Let me see me calculate it right. 1.5 times 1350. Let me check it again. You don't get this as the overtime rate. All right. Let's see. 1.5 times 13.5. That's what my calculator gave me. I don't know. 1.5 is same as 1.5. You want to use 1.5 expression. Look, 1.5 as a mixed number. 1.5 times same 13.5. Same answer. So it means that you're not using the calculator the right way. 1.5. So the 1.5 is a mixed number. You cannot put 1 and then put off. You can't do this in the calculator, get 1.5. You cannot do this. You cannot put 1 and then you put in a fraction like that. Well, I don't even know how to set it up on this calculator. This calculator won't even do it. So you can type 1 and then type space half and think it's 1.5. You have to put in the mixed number function in the calculator and put it as 1.5, the mixed number function on the calculator. The button that looks like this, A, B, C. I think there's a button looking like that. That's the mixed number button. Some calculator, it just shows it like this. A little thing here, and a little thing there, and a little thing there for the mixed number. All right? So that is it. We're calculating, we're not using the calculators properly. So anyway, so this is no Michelle learn from your mistakes. That's why we have to do the papers, you see? That's why we have to do the papers, so that we discover things that we're not doing right, and we'll fix them before the exam. We don't want to carry these simple mistakes into the exam room. That is why we need to do the papers and find out, for example, that we're not using the calculator the right way and learn the right way to use the calculator before the exam. Otherwise, you're going to go in the exam, think you do the right thing and actually do the wrong thing. That's why doing all these papers is so important, and you have to make sure you learn from them. Any mistake you make, you don't go and repeat it. You eliminate it. And that's why you have to merge the maths. So this is the rate per hour, and this is the total. So to get the number of hours worked, overtime hours worked, we just need to divide this total overtime pay by this overtime rate of pay. Simple as that. Right? So the overtime hours, the OT hours, comes equal to the OT pay divided by the OT rate of pay. And that will give you the answer. So we're going to divide the 303.75 by the overtime rate of $20.25 per hour. And that calculation will give you the 15. Let's look at it. So it's 303.75 divided by 20.25, 15 flat, 15 hours. Shown. The other way to do it, as I said, is to use the 15 hours and calculate what the pay would be. And you should get this as the amount of pay. But I'm leaving this method on the screen by calculating and getting the 15. But I go to that. All right. Next question. It says in August, 20% of Rhea's gross earning is deducted as tax. How much money does she have left after the deduction? So it's simple, guys. You don't have to calculate the deduction. You don't need to calculate the deduction. They're not asking you for the deduction. They're asking you for what she has left. So if she deducts 20% of her money, she has 80% left. So the amount left is equal to 80% of the total gross in August. It was in August, right? In August. And the amount in August, what is it again? It was this figure up here. 246375. 2463.75. That's what you have to do. You don't have to waste time and do the deduction. So it's 80% times 2463.75. And so that amount that she has left is 1971. That is the answer that she has left. The amount she has left after the deduction. If they ask for the deduction, you calculate 20%. Some people are going to calculate the 20% and then subtract, which is more work than you need to do. You need to understand that if you take off 20%, you have 80% left. And if there's a case where you're adding 20%, suppose you was getting some bonus of 20%, then you'll be adding 20%. So the new figure would have been 120% in that case. If she was getting 20% more than the gross pay, then the new pay would have been 120%, because it would be 20% more than the 100%. We need to deal with percentages in these simple ways. If you take off 5%, you have 95% left. If you add 5%, you now have 105%. Simple as that. Not every time you have to calculate the percentage value. Down here, it says Rhea invested $219 of her earnings for 3 years at a rate of 4.5 per year, simple interest. That is a simple interest calculation. It says, how much interest, they're asking us for the interest, does she receive after 3 years? So this question is asking us for the interest. So remember, simple interest formula is one that everybody should know. It is that the interest amount, I is the interest, is PRT divided by 100. Remember, the P is the principal amount. The R is the rate per year, percentage. And T is the time in years. Remember, the T has to be in years. If they give you the time in months, you have to convert it to years. So for example, if they say 26 months or 24 months is 2 years. So time T will be 2. T has to be in years. See, I'm repeating these things. If I give you 6 months, 6 months is half a year. So the T will be 0.5. In this case, the principal amount is $219. That's the amount invested. Times, the rate is 4.5%. You don't have to put in the percent because the percent is already taken care of by this 100 being under here. So the R is just 5.4. 4.5, sorry. You multiply that by the time of 3 years, I divide all of that by 100. And get the interest out here. All right, so it's a fraction. 219 times 4.5 times 3. All of that over 100. That's 29.56. Because it's money, we're going to put 29.57. Let's put 29.57. Let's put it here. So the interest amount we're going to write 29.57. That is the interest amount. Good. That question done. Next question. Don't need a calculator now. This question first wants us to factorize this thing. Two terms, we're looking for the highest common factor. So this is equal to, in terms of the numbers, the 3 and the 15, the highest common factor is the 3. In terms of the n here, there's an n squared here, and there's an n here. So out of those two, highest common factor is just the n. There's a p in this expression, but there's no p over here. So there's no common factor p. So 3n is the highest common factor. So like you're dividing each of these now by the 3n. So you divide this by the 3n, the 3 is divided out, that gone. Out of the n squared, you divide out of n, you're left with n inside here. Then this one now, you're dividing this by the 3p. So like you divide the 15, the positive 15 by the 3, you get positive 5. This n is factored out here already, and you're only left with the p over there. If you're not sure, you can just expand this back, and you should get that when you expand it back. So that is correct. That is it. And you check if this can be factorized any further. No. What's in the bracket here cannot be factorized any further, so you're done. This next question. The diagram below shows a quadrilateral with the length of its sides written in terms of x. So these are the 4 sides, all written in terms of x. X is in the expressions of the 4 sides. It says, write an expression in terms of x for the perimeter of the quadrilateral and express your answer in simplest form. So the perimeter is the sum of the 4 sides. So we're adding up all those expressions. We can do it quickly. We can look at the x terms first. So I have a 2x here and a minus 2x there. So those two eliminate each other right away. Then I have a 3x here and a 2x here. These two add to give me 5x. But these two eliminate each other, you know. So in terms of the x, I'm left with 5x. Let's just write it. 5x in terms of the x. Then I'm going to look at the numbers now. In terms of the numbers, I have a 15 here and a 5 here. Look for the easy numbers. Those two add to 20. And then this is a -1 and a -7. That's really 20 minus 8. Because the -1 and the -7 become -8. So 20 minus 8 is 12. So I'm going to put a plus 12. That is it. Quick and fast, nice and easy. But I give it that. Get something different? Anybody got that? Come on, man. It makes sense we lose mark on these things when you can check it 3 and 4 times. So you add up the x terms and you add up the numbers. You don't want to list them out and do it, same difference. All right? Next question says, the perimeter is 32. So it means that this thing is 32. Because the perimeter, remember this represents the third perimeter now. And they're telling us now that it is 32. It says, find the length of the longest side. And I don't want us to look to see which is the longest side. It looks like this one, you know. But I'm not going to trust that. I prefer to work them out and see which one it is. But to work them out, I need to see what the x value is first. So based on this information, this thing equals 32. So I'm going to write 5x plus 12 is 32. Then I'm going to subtract the 12 and get 5x equals 20 when I subtract the 12. Then divide by the 5, I get x equals 4. So the x is 4. Now that I know that x is 4, I can just calculate on each of these what the length of the sides are. So this one first. This 3 times 4 is 12 minus 7. So this side is actually 5 centimeters. This side, this 2 times 4 is 8. 8 and 5 is 13. So this becomes 8 plus 5, which is 13 centimeters. This is right along this side. Then this side now, this is 8 minus 1. This is 8 minus 1 because 2 4 is 8 minus 1. This side is 7 centimeters. Just making sure. Then this is now 15 minus 8 because 2 times 4 is 8. So this side is 15 minus 8. 15 minus 8 is how much? 7 centimeters. So that side along and it's just 5. So life stay. This longer than it and that longer than it. And so that side look long. So you cannot go by how the diagram looks, guys. See that? They work them out. So this one is the longest side, 13 centimeters. I'm leaving this on the screen, you know. I'm leaving this on my paper. These working out. I'm leaving them on my paper, 13 centimeters. Don't go by how the diagram looks. So 13 centimeters. It's the longest side. (13 centimeters). And I'm leaving these on my diagram up here. These things, I'm leaving them on my diagram. That's a part of my solution. Those workings there, it's a part of my solution. Remember the entire thing going into CSEC, you know, the question paper going back to CSEC. So you can put your working anywhere on it. All right? Just don't work outside the borders. I'll show you. Don't work, for example, outside here, outside these lines. Don't work up here, so. Don't work over here, so. Outside these lines. Just imagine that there's a line inside here. Look at it. Straight line between here. Straight line between here, down here. And they have a straight line down here. Don't work outside those lines. All right? Because what happens is that they cut up the paper and scan it. And they cut the paper at those marks. So don't work outside those marks. In particular, there are some cross hatch on the paper that you absolutely don't write in those cross hatch. Like at the end of the paper out here, sometimes you see something like a cross hatch here. Don't write in it at all, at all, at all. It definitely will cut this up. But to be safe, work inside these lines. All right? That was showed you a while ago. Everything important. Next question. That one done. This one now is for us to determine all the integers. We have to determine all the integers. The integers. What are integers? Positive and negative whole numbers. Determine all the integers which satisfy this inequality. So to do that, and we're talking about the interval is x, we need to make x a subject of this inequality. So it's a matter of transposing everything away from the x to make x a subject in the middle. Whatever inequality in a range like this, you want to leave x alone in the middle. So you can see what the range of values are. Remember, it's like you have two simple inequalities, you know, one on this side and one on this side. And you're trying to make this x a subject so we can apply the transposition to the entire inequality. Remember though, that because it is an inequality, if you have to multiply or divide with a negative number anytime, you have to reverse the signs, the inequality signs. You have to remember that. All right, let's go. The first thing I'm going to do, I'm going to move this 3. So I'm going to multiply through by 3. To get rid of this 3, because it's dividing, I have to multiply through by 3. So multiply all sides by 3. Multiply by a positive 3. So multiply each of the sides of this inequality by 3. Multiply this side by the 3, I get negative 3. Less than or less than. When I multiply this by the 3, it cancels this, and I'm left with 2 minus 4x. Then I put back the less than sign, multiply this 5 by the 3, I get 15. About to go so far? Then I need to move this 2. To move that 2, I need to subtract 2 from all sides. Subtract 2 from all sides. So I'm going to subtract 2. I still not going to reverse a sign because I did not multiply or divide by a negative number. You only reverse the inequality sign when you multiply or divide with a negative number. So I'm subtracting 2 now. So if I have negative 3, I'm going to subtract 2, it's going to become negative 5. The sign stays less than. I'm going to subtract 2 from inside here, so this is gone. So I'm left with the minus 4x. Note carefully. It is a minus 4x that is there. Then I'm going to subtract 2 from that side as well. It's going to become 13. Next, I need to get rid of this negative 4, but it is multiplying. So if I to get rid of that negative 4, I will divide by 4, negative 4. Divide through by negative 4 to get rid of this negative 4. That's what we're going to do next. Divide through by negative 4. But because we're dividing now, the negative sign, these inequality signs must be reversed in the next step. So now I'm going to divide by a negative 4 to see what the values is, to see what the values are, the range. So when I divide by a negative 4, this becomes a positive 5 over 4. Positive 5 over 4, that's 1 1/4. This sign is reversed to greater than. This becomes an x because I divide by the negative 4. This sign is reversed to greater than. This becomes negative 13 over 4. If you want to put the negative under here, same difference. It becomes negative 13 over 4. So this is our range of values now, we know. But let us write this so we can appreciate and understand a little bit clearer. It means that the x inside here is greater than negative 13 over 4, but at the same time, it is less than 5 over 4. Let me reduce these. So I can put another line. What I'm going to do, I'm going to turn this around because when you're writing this range of values, you normally have the smaller value on the left side, larger value on the right side. So I'm going to turn this all the way around to be aligned with how a number line would be. A number line go from the negative values over here over to the positive values over there. All right? So I'm going to turn it around. So I'm going to write it like this. X in the middle, and put this now over here. X in the middle is greater than negative 13 over 4. Greater than negative 13 over 4. And I'm going to write the negative 13 over 4 in terms of values now. It's negative 3 1/4. What is that? Negative 3 1/4, right? Negative 3 1/4. And the same x is less than, can I read it this way? It is less than 5 over 4, but 5 over 4 now is 1 1/4. We only want the whole number values in this range. So I'm going to put this on the number line so we can see it. I can write them down, but I'm going to put it on the number line so you can see it. It actually starts from negative 3 and goes up to 1. Let's put it on the number line so we can see it. So on the number line, if we were to draw a number line for this, 0, well, it's more on the left, so let me put the 0 more to the right. So let's draw that better. I can write the answers from here, but I'm just going to put it on the number line so we can appreciate it. So 0, let's say this is 1, let's say this is negative 1, negative 2, negative 3, and put negative 4 here. So the critical marks here now, let's put them on in red. Negative 3 1/4. Let me say you pass negative 3, you know. You reach over here, so. So you have one critical value there. That's negative 3 1/4. This is 1 1/4, so it means that you pass 1 over here. This is about 1 1/4 right here. So this is 1 1/4, and right here is negative 3 1/4. So it's the whole numbers where you want here. These are the whole numbers where you want. Put them in a different color, in purple. The whole numbers that you want are these. because your integers are positive or negative whole numbers. So your answers will be that list of values. -3, -2, -1, 0, and 1 will be your integer values. Let's write it here. So the answer right here now, the answer, integer values are x equals, let's put them in a set, -3, -2, -1, 0, and 1. That's your list of values. If you want to list them down vertically, no problem. I give you the marks same way if you just write them out. But those are the values that you must have. Hope everybody understand this. Understand this, guys? Those are your list of values. -3, -2, -1, 0, and 1. Integers are positive or negative whole numbers. Remember that 0 is a whole number as well. All right? 0 is a whole number. Whole numbers start from 0. Natural numbers start from 1. 1, 2, 3, 4, 5. But whole numbers start from 0. 0, 1, 2, 3, 4, 5. Then you can have positive or negative whole numbers. These are now your integers. Positive or negative whole numbers. Online, about to go to that. So a few persons online don't understand it. People not interested in this exam, no? Not interested. Think with 2 weeks to go. Think with 2 weeks to go online would have full up with everybody from the other class. So you go. I try to get 100% grade 1 in this class, but not serious. Not joke. Not joke about the thing. Let me draw the number. Let me finish the number line. So if you were to draw this on the number line, this inequality, then we would have to basically just join it like this. Just to show the number line so you can see it. Let me shift this over a little bit. That's it. All right, next question. Number 3. Number 3 says, the box below contains the names of 5 quadrilaterals. So we did this topic. It says, choose a name of one quadrilateral from the box that best describe each statement. So I want to use one of these names that best describe these 3 statements, one of each. So which one of them has no line of symmetry and has rotational order 1? Rotational symmetry of order 1. So trapezium, out of all of them, it will be the trapezium. But it's not all of trapezium do have the line of symmetry, you know. I can draw a trapezium like this, where this side and this side is the same length, and then it will have a line of symmetry down here. Right? But the one they said, the one that's best. I'm going to say it's a trapezium. What do anybody answer what I mean by rotational symmetry? By rotational symmetry. So rotational symmetry is like you have an object and you're rotating it. And it is a number of positions that after you turn it, number of positions that it will be in to match the original position. Give you an example. Let's say you have a rectangle. Let's use a rectangle. And let's say you start with a rectangle like this. I want to say that this side up here is side A as a reference side. Let's use that as side A. So rotational symmetry is when you're rotating this thing. So you're going to rotate this thing. So when I rotate it first, it's going to eventually come to here. And the A is now over here, right? The A is now over this side. Agreed? Agreed? I'm going to rotate it again. I'm going to rotate it again. It's now gonna come to here. See that? And then now we rotate it again. It's now gonna come to here. So the A is now gonna come back to here. So remember, this is where I started, you know. So how many times was the shape exactly like this? Right here. See that? The rotational symmetry is what? 1. Because only one time it comes back to the original position. Only one time. Let's look at an equilateral triangle. Everybody understand that? Good. Let's look at an equilateral triangle. What do you think the rotational symmetry are equal? I think they include the first one, you know? And it's something that I need to look up. I think it's either 1 or 2. It's something that I need to look up. I think it's the first one, and because it's 2 positions, is that the same? The rotational symmetry is of order 2 for the rectangle. Order 2, not 1, because there are 2 positions that it is the same. If you take an equilateral triangle like this, with the 3 sides equal, and I'm going to put the A up here. When I rotate it down like this, it's eventually going to look like this again. It's going to look like the same shape when I rotate it down. Let's copy it. Let's copy it. But this time, the A is now down here. See that? If I rotate this thing down this way. All right? And if I take it again, and I rotate it one more time, rotate it one more time. Come on. No, I don't want that. Delete. All right, copy this again. But this time when I rotate it again, this A is now over here. But in those 3 positions, it looks exactly the same, don't it? So the rotational symmetry is of order 3. Right? Because it's 3, the same way in those 3 positions, even though it's 3 different shapes. So that 3 different, because the A is here first, then the A is here, then the A is here. But all 3 of them look exactly the same. The order is 3. Eh? What's the rotational symmetry for order of rotational symmetry for a circle? For a circle. Eh? Infinity. Infinite. So no matter how much position you rotate a circle in, it's going to look the same. So it's an infinity for a circle. All right? So that is it. All right, let's continue. So this we say is the trapezium, based on this. I want the best one based on the list that is there. Next one says it has exactly 4 lines of symmetry. Exactly 2 lines of symmetry, and it has 4 right angles. Which one? The rectangle. It has 2 lines of symmetry. Why is it not a square? Because a square has what? A square has 4 lines of symmetry? Yeah, a square has these, and it also has these. See that? Those lines of symmetry. So 1, 2, 3, 4. We're talking about a rectangle. Now, a lot of people mix up rectangle all the time, believing that if you have a rectangle, somebody alone, open the door, please. Some people believe that in a rectangle, this is a line of symmetry. That is not true. That's not a line of symmetry. How a line of symmetry works is that it must be a mirror line. And look at this, why this is not a line of symmetry. Because this point, look at it good. Why this is not a line of symmetry of this rectangle? Because if you take this point, for example, and I'll go perpendicular to the mirror line to get the reflection, that would be over here. See that? So that's not a line of symmetry. The line of symmetry is supposed to be a mirror line. So this is clearly, this point, if you put it in this line of symmetry, is coming to over here, which is not on the rectangle. So the diagonal of a rectangle is not a line of symmetry. The common mistake people make all the time. All right? It divides it into two congruent triangles, you know, but still not a line of symmetry. All right? So the only two lines of symmetry the rectangle has is this one and that one. So that's why the angle here is, answer here is rectangle. And the last one now says, this shape has one line of symmetry and has but no rotational symmetry. No rotational symmetry. Meaning, I need to look up this rotational symmetry thing and I'll talk about it later. I can look a bit more details. Why is no? This one answers a kite, though, you know. One line of symmetry. One line of symmetry. Because a kite is like this. It has two sides that are adjacent to each other in length. And the only line of symmetry now is this one. But the point is, no matter how much different position you rotate that in, it will never ever look like this original position. Get me? It will never ever look like that original position unless you get back to the way it was before. So that's why they say is no. So it's a kite. That is it. All right. Let's continue. This question says the diagram below shows 4 lines, 2 of which are parallel. So these are the parallel lines. You can see that they are parallel because I have the arrows on them here. All right. Remember, once you have parallel lines, there are some angles you're looking for. Looking for Z angles. Looking for U angles that we call co-interior angles. You're looking for corresponding angles. Z angles, U angles, corresponding angles. Those are 3 of the main things that are formed when you have parallel lines. All right, and especially when they are crossed by a transversal line like this one. So these 2 parallel lines, what it is, you know, is that these 2 parallel lines will relate to that blue line in exactly the same way. They will cross that blue line at exactly the same angles. So for example, let's look at some of them. Let's look at some of them. You can pick up some of them right off the bat. For example, this 54 degrees on the here between the 2 lines. It's the same 54 degrees on the here now. See that? Same 54. Same angle on the here is under there. This angle out here, this angle between the transversal line and the parallel line is the same angle over here. We call them corresponding angles. Look here again. This angle here, which is a Q, is this angle right out here, say no? Look here again. This angle R, between the red line and the blue line, is the same angle between the red line and the blue line here now. Corresponding angles. All right? So the parallel lines will interact with that transversal line in terms of the angles in exactly the same way because they are parallel. So the angles are corresponding angles. But let's see what they want us to find. They want us to determine the values of Q and R. So they want Q first. Let me leave those lines in red and blue. So it might highlight a little bit better. So they want Q first. Q. So Q is this angle. I don't want Q first. I thought I would have asked for R first because these 2 angles equal because they are vertically opposite to each other. You know, if you have an X, right? Angle over here and angle over here equal, right? Call those vertically opposite. But I want the Q first. So let's see how we can get the Q. It don't matter if you want to calculate the R first, no problem. But let's say, oh, we're going to get the Q first. What you have to recognize, as I just showed you, is that this angle under here, which is 54, is the same angle under here as 54. These two angles are corresponding angles. So if I'm in the exam, I'm doing this. I'm putting this as 54 right here. So this angle is 54 degrees as well. And then total angle on a straight line right here through this point is 180. And therefore this Q becomes 180 minus 54. Yes? Another way to look at it is again to recognize that this Q angle right here is the same angle over here, so. Here, so. This angle over here is also Q right here. These two angles are the same. So this angle is also Q. So again, Q plus 54 is 180. So anyway you want to look at it, result is the same. So Q is 180 minus 54. All right. So I'm going to say Q equals 180 degrees minus 54 degrees. How much is that? 126 degrees. Then the one R. R kind of easy. Because R now is vertically opposite to the 54. So these two angles are vertically opposite. The angles are across from each other like that on the X. So you have the X this way. Let me draw it. All right. And you have the 54 here. And you have the R here. They are equal. And in fact, watch me now. Q don't have any degree on it, you know. Okay, if you look at the question, it says Q degrees. So let me take off these degrees. The value of Q is just 126. Because the question said Q degrees. So the Q is just a number. 126. The angle is 126 degrees. What's the 54, guys? Vertically opposite. And they didn't ask for any reason like that, so I'm just writing it. The R is equal to 54 degrees. Vertically opposite. All right? Vertically opposite. All right? That is that. Next one. Give a geometric reason why angle P is 71. Let's look at it. Why is angle P 71? Why is this angle... why is this angle 71? It is because of the Z. Let's draw on the Z. Let's draw it in green. If I come down this parallel line, come across this transversal line, and then continue along that parallel line. These two lines parallel. So I form a Z angle. So the angles inside the Z equal. See there? So this angle and that angle are the same. So the P equals 71 because of the alternate angles or the Z angles. The Z angles are equal. So I'm going to tell them that. Right? So the P equals 71 because alternate or what we call Z angles. Or what we call Z angles, alternate Z angles are equal. That's the geometric reason. 1 mark for that. Nice and easy. Next question. Transformation. Right here. It says the diagram below shows triangle X prime, Y prime, Z prime, X double prime, Y double prime, Z double prime drawn on the grid. So they don't show the original triangle XYZ. All right. So this one will give us two image triangles. It says triangle X prime, Y prime, Z prime is the image of XYZ. So they're telling us that this triangle up here is the image of a triangle XYZ after an enlargement of scale factor 2. So it means that this triangle is twice as large as the original triangle. Okay? This is the image after an enlargement of scale factor 2. That's the first thing. So the original triangle is smaller. It's half the size. And it's about the center point 5,1. So it's not about the origin. So you cannot use the enlargement matrix here. So it is as if we want to go from this image back to the object. So if you're going from the image back to the object, you're going to have to apply a scale factor of a half. Because a scale factor of 2 took it from the object to this image. So because we have the image and want to go back to the object, we're going to have to reverse that enlargement transformation by making now an enlargement of scale factor half from the point 0.51. And we're going to have to construct it. So we're going to put in the point 0.51 where that center point is first, and then construct it. So this is the center point for that enlargement. So remember that the scale factor of 2 would have doubled the distance from here. So it means that if you draw a straight line, for example, out to here, the image is half of this distance. The image point of this is half along this line, half that distance. So you need to calculate where half of this line is. Let's look at it. So what we can do to calculate, to find halfway of this is half the horizontal and the vertical movement, half the x and the y component. That would take us from here to here. Let's count it off and then half that distance. Let's count it off. Let's do the horizontal first. 1, 2, 3, 4, 5, 6 across. And 1, 2, 3, 4, 5, 6 up. So where that is coming from is 3 across, 3 up. See here now, let's do that part in purple. 1, 2, 3 across, 3 up. 1, 2, 3. So the original triangle, the original y is at this point. That is where the point y was. That's where this point was before the enlargement. And having done that, we don't have to do anything else. We know that the lengths are halved. So this length was doubled. So it means that it was originally just right here. Let's zoom it up, so everybody can see it. This length is 2. After an enlargement of scale factor 2, it means that it was 1 before. So this length gonna come back to here, half. So it means that this point was right here before. So this point is where x was, right here. And then this length down here, how long is it? 1, 2, 3, 4. That's doubled to 4. So it means that it was 2 before. So we're going to draw this 2 down. See there? 2 down. So it means that this point was right here before. That is where Z was. So that is Z. So that is my original triangle right there. And I can show my construction lines to confirm it. If I draw a straight line through here, here, and here. See there? And I can go through here, here, and there. See there? So those blue lines are like my construction lines. So that purple triangle is my original triangle. Notice it is half the size of the final one, but this purple one was doubled to that. And it's also half the distance from the center of the enlargement, because this triangle was originally doubled. The distance was doubled. So this is that question testing your ability to reverse an enlargement transformation. Nobody got this one right? Oh, no good, man. Now go on. Very good. I'm proud. I'm proud. So this is the point 0.51 right here. So this is where that triangle is. All right, very good. All right. So the question said, next question said, part 2. It says triangle XYZ is now mapped onto x double prime, y double prime by reflection in a line P. They want us to just state the equation of that line P. So basically what it is now is that, let me take off these lines. Don't need them. What it is now is that this triangle undergoes a reflection in a line to this triangle. And I want us to tell them the line. So remember that the mirror line is going to be halfway between the corresponding points. The mirror line becomes like a line of symmetry between this object and image of that reflection. So what is the length across here? We're going to half it. 1, 2, 3, 4, 5, 6. We're going to half that. So it's 3. 1, 2, 1, 2, 3. So this is the mirror line. That becomes the mirror line, this red line. That red line is the mirror line that reflects this over onto this. That reflects this point over onto that one. That reflects this point over onto that one. Note, this distance and this distance is the same. And this distance and this distance is the same. All right. So this line, which line is it now? It's a vertical line passing through 2 on the x-axis. And so it is x equals 2. That is the line P. X equals 2. All right. So basically that is it. X equals 2. So the answer for that is x equals 2. Line P is x equals 2. That's the equation of that vertical line. All right. Hold on a second. Somebody just messaged me. Hold on a second, guys. Hold on 1 second. Hold on a second. Hold on a second. Here is this thing. All right. Hold on 1 sec. Hold on 1 sec. All right. Let's continue. Next question. Functions. So this question gives us these 3 functions, g, f, and h. First thing we want us to find f of a half. Means that we're going to plug half in the f function to get that. Simple as that. This then becomes 2 times half where the x is, minus 1. That works out to be 0, because 2 times a half is 1, 1 minus 1 is 0. That is it. Then they want h of 0. H of 0 means that we're going to put 0 in the h function where the x is up there. So this is going to be simply 5 to the 0. 5 to the 0, putting 0 where the x is. 5 to the 0 is 1. If you want to work through the calculator, same thing. It's going to be 1. Any number raised to the power 0 is 1. All right, next one. They want g squared of negative 3. What we have to do, recognize with this one is that the g squared means g of g. So it means g of negative 3. And what it is, we want to work out the g of negative 3 here first. All right, before we apply the other g. So we're going to do g of negative 3 now. So it means that we're going to plug this negative 3 back into this g function. Let's write what g is down here again. Remember, g of x, remember, is 3x plus 2. All right? Let's just put it here. So if we're doing g of negative 3, means that we're putting negative 3 there. So inside this red bracket, we're going to get 3 times negative 3 plus 2. 3 times negative 3 plus 2. That's what this g of minus 3 becomes. And this now inside the bracket works out to negative 9 plus 2 is negative 7. So we are now working out g of negative 7. Because the term inside the bracket is negative 7. I'll put these in the red brackets again to make the distinction. So the g of 3 inside here is negative 7. And so now we are working out g of negative 7. We're going to plug the negative 7 in the g function again. So this then is going to become 3 times negative 7 plus 2. That's negative 21 plus 2. That looks like negative 19. That's his answer. Negative 19. But okay with that? Good. The next part wants us to find g of f and give the answer in simplest form. Let's write it. We want to find g of f of x. Let's write out the g of x. Now remember the f of x, what was it again? 2x minus 1. And the g of x is the 3x plus 2. Now this g of f, it means the f into the g, the inner one into the outer one. So it means that we're taking this f and we're putting it into the g where the x is right here. That is how we form this g of f. All right, let's shift it down and put it here. And so it becomes equal to 3 times where the x is in g, we're going to put all of f there. 2x minus 1. And they add back this 2. All right, let me just do some shifting around. Shift this over more to the right and shift this back up. Put a line between them. All right, and then we'll simplify this because that's a simplify. So this 3 times 2x is 6x. This 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. So it becomes 6x minus 1. That's the final answer. 6x minus 1. But go to that. All right. Next question. The one g to the minus 1. G to the minus 1. So it's the inverse of g. So remember now that the g function is 3x plus 2. I'm just leaving off the of x for now and just write this instead of as just g. Some teachers call it y, same difference. Then we're going to inverse it. So this g, which is the range, becomes the domain in the inverse. It becomes x equals 3 times. This domain on the function becomes the range on the inverse, which is written g to the minus 1. Some teachers put y there, no problem. Plus back this 2. Then we're trying to leave this as a subject now. So like this is the function and this is the inverse. But we're trying to make this the subject. Easy. Transpose the 2, make it negative, and then divide under the 3. Can do that in all one step. So you're going to get x minus 2 when we subtract the 2. And then this 3 that is beside the 3g, we're going to divide it under here. And so we're going to get 3 under here. That is g to the minus 1. And now that we're done, we can basically just write the answer right here in a box. This becomes really g to the minus 1 of x. So we can write g to the minus 1 of x. But this is really g to the minus 1 of x becomes this expression. x minus 2 over 3. So this now is the answer that you have gotten here. Simple as that. Next part says, hence or otherwise determine the value of x when g to the minus 1 is equal to 4. Hence or otherwise. This can be done two ways. Let's do it two ways. Let's use the hence method first. The hence means that you have to use this thing that you just calculated. That's what the hence means. Use that thing. So what they're basically saying is that the g to the minus 1 is 4. So it means that this thing equals the 4. Because remember that thing is g to the minus 1. So the hence method is where we put this thing for the g to the minus 1 equals 4. X minus 2 over 3, that's the g to the minus 1. You put it equal to 4. And you're solving for the x. The hence method this time is a longer method actually. I can tell you. You're going to multiply the 3 and get x minus 2 equals 12. They're going to subtract the 2 and you're going to get x equals 10. No, not subtract, add. You're going to add the 2. 10 negative 2 and add it over, you're going to get 14. X is 14. Or, this is an or method now, which is an otherwise method. You don't have to do it both ways in the exam. Just do it one way. But I'm just going to show you. The otherwise method is to know that if g to the minus 1 of x is equal to 4, then you can take the g to the minus 1 and put it on the 4 as g of 4. It means then that the x is equal to g of 4. Because if the g to the minus 1 is taken from x to 4, then it means that the g of 4, the g is taken from 4 to the x. That's what it means, because it's a one-to-one function, it's the inverse. So all we have to do to get x is plug the 4 in the g function. What was the g function again? 3x plus 2. So we're doing g of 4, which will become 3 times 4 plus 2. You get the same 14. So you could have done it that way as well. More maths equals better maths. All right, it's only one mark enough, so you're not going to do it both ways. But you could do it any one of those two ways. That question done. Next question. Number 5, statistics. This question says, the cumulative frequency diagram shows the information about the distance d meters that each of 100 students walked on a particular day. Remember that a cumulative frequency curve is a way of lining out these 120 students from the ones who walk the shorter distance down here to the ones who walk the longer distance at the top. In ascending order. It's the best way of arranging the data in ascending order. Because you don't know the actual distance walked, but what you know is how many students walk less than or equal to certain distances. That's what it shows. All right? So that's what the graph shows. So even though they put distance down here, we're going to put less than or equal to distance on it. I can put less than. I know what is less than or the equal to, because this first question is saying, how many students walked at most 1 kilometer? That term, at most 1 kilometer, means that 1 kilometer is the most. So it means less than or equal to 1 kilometer. That's what you're trying to find. How many persons walk less than or equal to 1 kilometer? So based on that, I'm assuming that this is a less than or equal to graph. So it shows less than or equal to distance walked by the students. You know, really meant to show the actual distance walked by the students. You know, you can estimate the actual distance walked by the student, but it's derived from knowing how many students walk less than or equal to certain distances. And so that's what you get from this graph. So to know how many persons walk less than or equal to 1 kilometer, all we need to do is find the 1 kilometer on the graph, and it will tell us how many persons walk less than or equal to 1 kilometer. Because at most 1 kilometer means 1 kilometer or less. So find the 1 kilometer on the graph here. come up on the graph. And you have to make sure you read the scale properly. So you come up on the graph here. And it's on this line. So we're talking about the mark right here, or the student right there. So remember now, if you read the scale properly, right here will be 10, you know. Right here will be 10. So it's 5 lines up to 10. So like 10 divided by 5 lines means that each line is 2 students. You see that? So every one of those like a small millimeter mark is 2. So that's 2, 4, 6, 8, 10. So every one of those like a small mark is 2. So right here, therefore, this will be 30. 32, 34, 36. Beautiful. 36. So this is 36 students. So all 36 students down under here walked a distance down here, less than or equal to 1, corresponding to this part of the graph down here. So the answer is 36 students. So the answer here is 36 students. The number of students who walk less than or equal to 1 kilometer is 36 students. 36 students. You could just write 36. That's how many students. So you can just write 36, but I'm going to write students still. 36 students walk less than or equal to 1 kilometer. Next question. It says, using the cumulative frequency graph, determine an estimate for the median. So remember, the median distance is the distance walked by approximately the student in the middle of that distribution of a students in ascending order. Since there are 120 students, the position of the median is half of the 120, which is the 60th student. So you want to know the approximate distance walked by the 60th student. That is the median distance. So because there are 120 students in all, the median one is at the 60th mark right here. So this 60th student is the position of the median, which is the symbol for the median is Q2, the second quartile. This right here. But that is not the median, that's just the position of it. The 60th one, because there's 120, so you go to half of 120. And they come across on a graph. To here, and you read it down. So it appears to be right on this line. So we need to know that distance right there. You have to read the scale properly. Right there. All right, so that is Q2 right here. Let's look at the scale. So basically, every other line is 0.1. Because this is 0.5 divided by 10 lines. So it means that every other line is 0.1. See that? So see here, this is 0.1, 0.2, 0.3, 0.4, 0.5. Every other line is 0.1. Every other of these small lines is 0.1. Because like I take 0.05, I divide it by, there are 10 lines there. So each line is 0.05, right? I divide it by 10 small lines. So each of those, no, not 0.05, 0.5, sorry, 0.5. So each line is 0.05. So 2 lines is 0.1. 2 times 0.05 is 0.1. So each of those lines is, every other line is 0.1. So be mindful of that. So ready now, we're trying to come to here. So right here is 1. This is 1.1, 1.2, 1.3. This is 1.6. Let's go again. Have it right? Let's go again. 1.1, 1.2. This is not right. I don't have it right then. I don't have it right. I don't have it right. Huh? I don't have it right. It's every 4. Hold on. 1.1, 0.1, 0.2, 0.3, 0.4, 0.5. That's it. So every line is 0.1. So this is 1, 1.1, 1.2, or 1.3, 1.4, 1.5. Okay, I said it right the first time. All right, so this is 1.3, 1.3. This is your Q2, 1.3 kilometers. So the median is 1.3 kilometers. 1.3 kilometers. And what you showed on the graph with those lines is basically saying how you get the 1.3. So you only need to just write it here. The graph is showing with those lines that I've drawn, you have to leave them there. They are showing how you got the marks, all right, the values. Next thing they want is the lower quartile. So the lower quartile corresponds to the 30th student. I want to know, because 1/4 of the position of Q1 is 1/4 of 120, or you can say it is halfway between the 0 and the 60 down here. Halfway between the 0 and the 60 is 30. So the first quartile or the lower quartile, the position of it is right here, the same 30 right here. That's the position of Q1. You can do a 1/4 of 120 to get it, 120, which is equal to the 30th student, or you can say it is halfway of the bottom half, halfway of the first 30, the first 60, bottom half, which is 30. So we need to know that's a portion of Q1, 30. So I have to come across on a graph and read that. It's on this line. Look at it. That's where it meets the graph. And it comes down on this line. Talking about right here. So it says 0.5, 0.6, 0.7, 0.8, that is 0.9. So right here is 0.9. This is Q1. So Q1 is 0.9 kilometers. Q1 is 0.9 kilometers. Let's write it. So this is 0.9 kilometers. Then here now they want the interquartile range. So to do the interquartile range, remember it is Q3 minus Q1. We have Q1 already. We have to go calculate. We have to go find Q3. So if we go back on the graph and find Q3. Now Q3, the portion of Q3 is midway the top half. The halfway mark between 60 and 120. That's the 90th student. Or we can say it is 3/4 of the 120 student. That's the position of it. That is the 90th student. That's the position of Q3. So we need 90. So the 90th student to be right here. The 90th student is the position of Q3. Position of Q3. Not Q3 itself. There's a position of it. The third quartile student is the 90th student. I want to know the distance that the 90th student walked. That approximately is the upper quartile distance. So you come across on the graph again, one more time. Come across on the graph here. And it's on this line that we're going to draw down. Use the rule and do it. Don't do it free-handed like me. My device can't draw it straight. All right, so you come down on the graph. And it's right here. So what happened now is that this would have been 1.6, don't it? So this is actually then 1.55. What is that? This would have been 1.6 in a look. This would have been 1.6, 1.7, 1.8, 1.92. So let's mark it again so you can see it. This mark right here is 1.6. The mark that we want is halfway between the 1.5 and the 1.6. That's 1.55. So our Q3 right here, let's put it like this, is 1.55. That is our Q3. Let's write it better. 1.55 is Q3. This one. So Q3 is 1.55. So then this calculation becomes 1.55, that is the Q3, minus the Q1 is 0.9. What is your code? What is that? 1 point, what is it? 0.1? 0.65, and you must put kilometers on it. It's a distance. Interquartile range of the distance, 0.65 kilometers. Next question says, a student is chosen at random. What is the probability that a student walked more than 1.5 kilometers? More than 1.5. So the graph is going to show you how many persons walk less than 1.5, less than or equal to 1.5. The rest of them would walk more. You understand? The graph is going to show you how many walk less than or equal to 1.5. The rest of them at the top would have walked more. That is the number that you want. Let's look at it. So 1.5 kilometers. We want to see how many persons walk less than or equal to 1.5. So 1.5, let's use a different color now. Let's use the purple for this one, or the green. So the 1.5 is right here. So you come on the graph for the 1.5. Right here. That's the 1.5. Look at it carefully. It looks like it actually passed this mark, you know, and gone up to here. So I'm going to take it up to there and count it as this one. It don't look like this one. It's above that. If you look at it closely. All right. It's giving me, that's 82 students walk less than 82. Walk less. So the rest of them at the top up to 120. The rest of them up the top walk more. That's 120 students minus 82. How much that work out to? 18? No, not 80. What may I say? What that work out to? 120 minus 82 is how much? Huh? What is that? 38? Huh? 38. That's 38 students walk more. So everybody down here walk less. 82 of them walk less. 82 of them walk 1.5 or less. The one who walk more. So the rest of them. So the 120 minus the 82, that's 38 students. So the probability of walking more than 1.5 is 38 out of the 120. See here, the probability of doing more than 1.5 kilometers is equal to 38 students out of the 120. Expressed as a fraction. Divide this by 2, I get 19 over 60. That is the probability. All right. Next question. Gives us a table now. So this now we will extract values from the graph. It says, complete the table below and use the information to calculate an estimate of the mean distance walked by the students. So let's start the sum column for us here. This is our sum column right here. F times X. And notice they're using the midpoint values to represent the group values. I don't know the actual distance walked by the students, so you're using the midpoint values. Now watch this now. This one is to fill out. Because if you look here, these values going up by 0.5. The lower limit value is going up by 0.5. The upper limit value is also increasing by 0.5. And so the midpoint values will also increase by 0.5. So right here, we just need to add 0.5 to this. So it's going to be 1.75. So this is 1.75. Then we need to know the number of students here and here now. All right? So, what you can know, you can look at the graph and see how many students walk between 1.5 and 2. How many students walk between 1.5 kilometers and 2 kilometers? So we're going to go on the graph and look at that to get that range of students. 1.5 and 2. Now, we have found some stuff already. Remember the 1.5? We already know that was 82. Remember? 82 students, right? Then we need to know for 2 kilometers, how many students. So we can know how many people between them. We don't have to work out everything. So go back up on the graph now and look how many persons walked less than or equal to 2. Then there's a number of students between those two for that range, or for that interval. So you come up on the graph right up until you reach the graph. You see how many students I'm talking about. Let's look at it. It come up to halfway between this line and this line. So I'm coming across the middle right here. Right in between here. That's where it is. Right in between there. Come all the way over to the graph. So here. Now this is 110. This is 110. This is 112. This is 114. So I'm saying that this mark is 113. 113. So the number of students in this range between who walk 1.5 to 2 is 130 minus 82. That range, 113 minus 82. The number of students falling in this region between 1.5 kilometer and 2 kilometer. How many students that fall in between there? The difference between this 113 and this 82. That's the number of students in that little region right there who walk between those two distances. 130 minus 82 is how much? 31. So I'm going to put 31 inside here. So here, this is the one that we did. So this is 31. Let's write how we get it on the paper. So it's 113 minus 82, which is 31. Now, so once you have that value, you can complete the table now, and then double check it. Because to complete this number of students, remember the total number of students is 120, right? So this is to subtract to see how many we need to go there. Or if you like, you can go and look how many students between 2 and 2.5. If you want, you can do that too. But we can just add up these, and subtract from the 120 to see what goes here, and then we can go double check to see if that range is correct. Do that for me. Add up these and this, and then subtract from 120. Do that for me. So this value inside here, let's mark it. This value inside here is going to be 120 is the total minus the sum of these. That's the 12, the 24, the 46, the 31, and the 2. You subtract the 2 too? You subtract this 2 as well? That's how we're getting that value. Just showing the work. 120 is the total. I'm subtracting all of these that I have already and the 2. What you get it for yourself? How much you get? How much? 5. All right. What we're going to do now and check and see if this 5 is correct. We're going to check to see if the number of students between the 2 kilometer and the 2.5 kilometer is 5. Let's go and check it. Let's go and check it. The 2 and the 2.5. All right. So remember that this mark corresponds to your 2, right? When I look now for the 2.5, so 2.5 here. So just using the graph to double check to see if 5 is correct. So this will be the 2.5 line. So you come up on the line. You don't have to draw on the paper. You could just look and see in the exam. But I'm drawing it for you now. So all these drawings that I'm doing now, you just look on the exam paper and see and check. So you come up on the graph here. And it comes up to this mark right here. And I come across here now. to see what that is. And that will be 118. But this is 120, you know. So 2 below 108, 2 below 120 is 118. So you see it is correct. 5 students in that range. You see that? Yes, sir. 5 students. Good. So you can accept your values. That's 5 students in that range, in that interval. So based on that, you can accept your answers, you accept your values. All right, so that's 5. So 5 is correct. So the graph shows us that this is 5, and the calculation is basically confirming that this is 5 right here, because we calculated it. So now that you have all your values, we can complete the sum column. So what you're going to do for me is multiply this F by this X. Work it out for me. 31 times 1.75 to get this value. What is it? What I get? Not take too long, man. How much? That 32.75. That answer there, you know. I can't write. 31 times 1.75. 54.25. 54.25. And then I'm doing 5 times 2.25 next. 5 times 2.25. That's 11.25. 11.25. All right. So to get my sum of fx now, I need to sum this column, sum it. So let me extend this table down. Let me extend this table down. This is going to be my sum of fx, sum of f, sorry. This is the n, number of students, which is the sum of f. And this one is going to be my sum of fx. Sum of the sum of fx. That's like the estimate of the total distance walked by all 120 students. What is the work out to when you add up these values? And write them out on the calculator. So it's 3 plus 18 plus 57.5 plus 54.25 plus 11.25 plus 5.5. I get 149. 149.5. 149.5 kilometers. The total distance walked by all 120 students approximately. So the mean, remember now, X bar is the sum of the sum. It's the sum of the sum column over the sum of the frequency or the number of values, which becomes this value divided by 120. 149.5 divided by 120. That becomes the mean. So it's 149.5 divided by 120. That's 1.246. Let's give them that. I like to just do 3 significant figures still, but it's all right. Kilometers. I'm going to give them that this time. That is the answer. You could have put 1.25. They'd accept that, right? 1.25. 1.25. If you correct it to 3 significant figures, kilometers. And that is it. All right? But go to that. All right. Next question. Number 6. All right. Number 6 gives us this diagram. It says, at a track meet, a cylindrical container fitted with a pipe as shown, diagram below is used to serve water to athletes. It says the cylindrical container is 12 centimeters in radius right here, and has a height of 20 centimeters right there. That's on the diagram. And it is completely full. It's completely filled with water, and it's piped into the bottom, and the pipe fitted to the bottom of the dispenser dispenses water into cone cups. All right, so this cylinder is dispensing water into this cone cup using these pipes under here. All right, that's what the basically is saying. It says the cone-shaped cups have a radius of 3 centimeters, which is shown on the diagram here, and a height of 8 centimeters on the diagram. So everything that they have said is represented in the diagram. So we don't need to go back. Remember, this cylinder is totally filled, right? Question says, calculate the volume of water in the cylinder in liters. Write your answer to 2 decimal places. So we need the volume of a cylinder. Volume of that cylinder is pi r squared h. It's on the formula sheet, or it's the cross-sectional area of the base times the height. Pi r squared h. So the volume of the water in the cylinder, let's call it volume in cylinder, equals pi r squared h. Did they tell us what to use for pi? Usually these questions tell you. They don't tell you, you use the pi on the calculator. All right? But since they don't tell us what to use for pi, use the pi on your calculator. All right. So this then becomes the pi on the calculator times the radius of this cylinder is 12. This is 12 squared. Let me write it here. So pi times 12 squared, and the height, remember, is 20. All right. So it means, therefore, that that volume becomes what? And this is going to be in centimeters cubed, because we're using centimeters of far. Somebody work this out for me. Or let me work it out. So when they don't tell you pi is a pi in the calculator, pi times 12 squared times the height of 20, I'm getting 9047, call it 0.8. 0.8, and that is cm cubed, but I want it in liters. So remember that 1,000 cm cubed make a liter, right? And actually I told you that here in the question, 1,000 cm cubed is a liter. So to go from this amount of cm cubed to liters, we just need to divide by 1,000. 1, 2, 3. So decimal point coming here, and I'm supposed to give it to 2 decimal places. So divide by 1,000, the decimal point is coming here. We're gonna have 9.0478 liters. This is gonna be at 2 decimal places. Use this 7 to correct that 4, turn it to 5. So it's gonna actually work out to, let me shift this over. It's gonna actually work out to 9.05 liters. So this becomes 9.05 liters. That is it. But I want it in liters. 9.05 liters is the full capacity of the cylinder. All right, when it is full, the volume of water in the cylinder in liters. Next question says, water flows from the cylinder, the cylindrical container, along the pipes into the cone cups at a rate of 7.8 milliliters. No, this is not liters, you know, milliliters per second. All that means is that each second we get 7.8 milliliters. That's all that means. So after 2 seconds, you get 2 times this. After 3 seconds, you get 3 times that. That's all that means. Every second, you're getting this amount of milliliter in a cup. After 10 seconds, you get 10 times this. So this is not complicated, guys. Remember, this is milliliters. We just calculate the thing a while ago in liters, you know. This is milliliters. Remember, it's 1,000 milliliter make a liter. 1,000 milliliter make a liter. In fact, a milliliter and a cm cube is the same. 1 cm cube is 1 milliliter. Because 1,000 milliliter make a liter, and 1,000 cm cube also make a liter. So 1 milliliter is 1 cm cube. 1 milliliter is 1 cm cube. All right, it says calculate the time taken to fill 1 cup. calculate the time taken to fill one of the empty cone cups. So we need to find out is what is the volume to fill a cone cup and divide that by this rate to see the time that it will take. Because I put in this amount every second. So we need to know how much we need to put in there, divided by this rate, and then we will know the time. All right? And this is the formula for the volume of a cylinder. 1/3 pi r squared. Of a cone, sorry. 1/3 pi r squared each. So for the cone, let's do it this way. The volume of a cone is this formula. 1/3 pi r squared h. So since we have the formula here, we don't have to write it again. Let's put in the values. 1/3 pi times the radius of the cone is 3, right? And the height of the cone is 8, remember? That's what I said, right? The radius is 3. Yes, the radius is 3 and the height is 8. So that's going to give you the volume of a cone. So we're working that out to get the volume of a cone. So it's 1/3 times pi times 3 squared times 8. So it's 75.39. Let's do 3 significant figures and put 4. To the nearest second. 79.4 milliliters to fill a cup, approximately, right? So you're going to divide this total milliliters, that is when the cup is full, by this rate that they fill it per second. So the time taken to fill it is this amount to fill it divided by this rate. So time to fill becomes 75.4 over 7.8. And that answer is going to be in seconds. So we can actually take this now and put 75.4 divided by 7.8. And they said to the nearest second. So we get 9.6. To the nearest second is 10 seconds. 10 seconds. So this gives us 9.6 seconds. To the nearest second, I want to say approximately 10 seconds. The question said to the nearest second. So give the nearest whole number. 10 seconds. All right. Next part now says, determine the number of empty cups. Determine the number of empty cups that can be completely filled from the container. So the first thing we have to do is work back in the same unit. The volume of the cup, oh, this is milliliters to put here. This actually should be cm cube, but cm cube is milliliters, same thing, right? This is cm cube. Make a mistake, yeah. This is cm cube. But the thing is that a cm cube and a milliliter is the same. So that's what you have to know. So this 74.5 cm cube is also 75.4 cm cube is also 75.4 milliliters. That's what it is with this question. All right. So let's put a note out here that a milliliter and a cm cube is the same. All right. Let's put a note up here. 1 cm cube is the same as 1 milliliter. All right. So when we get this cm cube is actually milliliters as well. All right, so that's why we could divide this as milliliters by that. All right, that is it. So now we want to calculate the amount required to fill it, right? The number of cups it will fill, right? So number of cups it will fill that the container will fill is the total volume in the container divided by the volume in each cup. The total volume in the container divided by the volume in each cup. So number of cups equal the volume in the cylinder divided by the volume in a cone. But I can appreciate that. And we have to be working in the same unit. So I want to work in cm cube. So let me shift this over some more. So the volume in each cylinder in cm cube was what? was this. That's what I want to use. 9047.8. 9047.8. 9047.8 cm cube total. I divide them by the cm cube in a cup. This 75.4 cm cube to know how many cups they need. And they give it now. Remember, it's a total full. So any decimal that you get on this, you can't include it. I thought they say completely filled, right? So let's see. So it's a fraction 9047.8. I'm dividing that by 75.4. So we're getting 100. That look like 120, you know. I'm going to say 119 because it don't quite reach the 120. I'm going to say 119. It don't quite reach the 120. Based on the values that we rounded off. All right. I guess we put the 120, they give it a marks, right? But let's put 120. That's all right. 120 cups. Because maybe if we didn't round this off so much here, would have gotten it. We didn't round it off. Let me try something. So I'm going to put back this calculation under here. So I'm going to put the fraction 1/3, put the exact value, times pi, times 9. 3 squared is 9, times the 8. See, 120. Okay? So if I didn't round this off so much, I would have gotten the 120. That's what I'm saying. See that? So it's actually full 120 point something. So it's going to fill 120. So 120 cups. All right. And that's why it's so important sometimes to work with the 3 significant figures and so on. All right. That is it. That is it. Next question. Number 7. Pattern question. Question says, a sequence of figures is made up of lines of unit length and dots. Lines form a series of octagons and squares. All right. The dots are placed at each vertex. The first 3 figures in the sequence are shown are solid and irrelevant. So they want us to complete this for the 4th figure. See it? Figure 3 in the sequence is shown by itself below. Add lines of unit length and dots to figure 3 to correctly represent figure 4. So like the start figure 3 for us, and we need to add on 3 to get figure 4. So let's look at what they're adding on. So from this to this, what did they add on? Let's look at what they added. They added this octagon. And then they added this square at the top. That line, and that line. But actually, this piece was added in, just that. That was there before. And this line. And then the dots that they added are here, 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 and there. These were already there. This was there and this was there already. See them there? And this line was already there. This line. This line was already there. This line was already there. And this line was already there. So what I've marked in blue is what was added. So that's why you have to add on to the figure 3. All right. So all I'm going to do is use the technology that I have on screen. And don't be jealous. Move this down and add it on there. And that is my figure 4. Don't be jealous. You have to draw it. All right, that's my figure 4. Just like that. Very good? All right, you have to draw it. Cool? All right. Osh. Next one says, the number of dots D and the number of lines, number of unit lines that form the perimeter of the shape P form a pattern The values for D and P for the first three figures are written in the table below. Study the pattern of numbers in each row of the table. Complete the rows numbered 1, 2, and 3. So if you look at the pattern and complete these rows, and they have a formula row down here. I like to do the formula row first because it helps us to find the values in those other rows sometimes. So let's look at the formula row, especially when it is type where you're adding the number of values each time. So here they keep adding 8 plus 8 plus 8. They keep adding 8. So because they keep adding 8, 8n is a part of the formula. But the first figure already has 8. 8 times 1 is 8. So the formula here is just 8n. Done. In this column, they're adding how many? They're adding 6 plus 6 plus 6. They keep adding 6. So because they keep adding 6, 6n begins the formula. But the first figure has 8. 6 times 1 is 6. You have to add 2 to make the 8. And wake up a girl for me. Touch her for me. Touch her. Touch a girl. Touch her now. Huh? Get up, man. Get up. Get up. All right? That is the formula. So we're going to complete now. So for this row, we can just add another 8 to this and get too much. 32, or drop the 8 on this. 32. Okay, add a what to this? Add a 6 to this and get 26. Or we can drop the 4 on this. 6 4 is 24 plus 2 is 26. So this is 26. Then for this row, this formula equals that. Okay, and find out what the n is right there. Let's work it out over here. So in this row, for here, we know that the 6n plus 2 is equal to 86. Subtract the 2, you get 6n equals 84. Then divide by the 6. How much you get? How much you get when you divide by the 4? 86 divided by, no, divide by the 6. 84 divided by 6 is how much? How much you get? How much? 14. All right, so that's 14. So know that 14 is the figure number over here, 14. And since that figure number is 14, we'll just drop the 14 on this now. 8 times 14 is how much? Right here. Right here becomes 8 times 14. How much can I get? 112? 112? Yes. 80 plus 32. All right. And the table done. Now come down here, so now, and it says, for any figure n greater than 1, the number of dots D is greater than its perimeter P. So you can see it here, sir. This figure is greater than that figure. Except for when n equals 1. When n equals 1, they're equal. But after n equals 1, this figure is greater than that. All right, that's what they basically say. It said determine the value n for the figure in which the difference is 36. So what they want is when the D minus the P equals 36. That's what the question wants us to tell them now. When the number of dots minus the perimeter, because the D is always greater than the P, is equal to 36. What figure n is that? This is the formula for D. So we're going to put 8n for the D formula minus. This is the formula for the P. Put it in a bracket and be careful. 6n plus 2. That equals 36. You're solving that for n. The D formula minus the P formula must equal 36. And you're solving that for the n. So careful now. 8n minus 6n is 2n. Then we have a minus 2. So it's 2n minus 2 equals 36. Then we can divide 2 by 2. Let's shift this over and make it smaller, I should say. We can add the 2 over here and get 38. And get 2n equals 38. And then divide by 2, we get n equals 19. That's the answer, 19. Anybody get that? Anybody got that part? Don't tell a lie now. Want to get n equal 19 for true? Oh, that's so no good in our class, on the bright man. Very good. And some people won't decipher all of this information, but that is it. Very good. All right, let's go. Next question. Number 8. That's a quadratic. It's going to give you a front shape right away because the square term is negative. So it's going to have a front shape. It's a quadratic with a front shape. So it's going to have a maximum. You have to be mindful of those things. This 3 is going to be your y-axis intercept. So this is a function, and as usual, I want us to complete the values in this table. Right away, I can see where my line of symmetry is. Remember, the y values, once x values are on the same interval, and these are going up by 1, then your y values are symmetrical outwards from the line of symmetry. So it means that the line of symmetry, based on the fact that you have a 9 here and a 9 here, the line of symmetry is right in between here. That's where the line of symmetry is. Halfway between the 2 and the 3, that's 2.5. So my line of symmetry, based on this, is where x equals 2.5. I know that to begin with. Halfway between x equals 2 and x equals 3 is x equals 2.5. The more things you know, the better. If you can decipher that from now, you're good to go. So 2.5 is where my vertex is. My maximum point is at x equals 2.5. Let me put it under here. This is where x equals 2.5. And at that point, because they don't give us that value on the table, you know, they don't show us where the maximum is, you know, but you know it as a maximum. I can easily determine that that is the line of symmetry. The line of symmetry passes through the vertex. It is where x equals 2.5. We can work out the y value there by plugging the 2.5 in this function to get a maximum value. So this is really the xt value, the x value, the turning point, you know, this. And so the yt value this time, this is the xt value. So the yt value, we're going to plug the x inside that and work it out from now. It's going to become 3 plus 5 times 2.5 minus 2.5 squared. Somebody write that out for me, please. Wanna get? I'm working out the maximum point from now, because they didn't give us as a point, but we need to show it on the graph. Nobody helping me. Nobody is helping. Can you imagine that? No help. I worked out myself. 3 plus 5 times 2.5 minus 2.5 squared. 9.25. Number here. 9.25. So it means that my maximum point is this xt value and this yt value. 2.5, 9.25. So you see, it's at a value greater than a 9. The maximum value cannot be repeated as a y value. The maximum value is a single maximum value. So it cannot be 9. Because the maximum value is at a vertex point on the graph, the one single point having that one maximum value. And pay attention now and stop talking about much. All right. Let's go. That's the maximum value. Then I want us to complete this table. Now, I prefer to use the knowledge that you have that the function is symmetrical. The values will be the same. The y values will be the same outwards from that line of symmetry. You can look at it and know some of the values. All right? All right, let's look at it. So, firstly, when x equals 0, 0 here and 0 here, you're going to give me 3 in the bracket. But I can say that? 3. So I know that this value right here is 3. So the corresponding 3 there, so see that? So I know then that outwards from 3 is to -3. So outwards from 3 out here So this has to be negative 3 as well. I don't have to work it out. Outwards from 3 is negative 3. Outwards from this 3 is negative 3. So this is negative 3. If you want to work it out, you can work it out. But then these two values between the 3 and the 9 is the same. I have to work out one of them. If I had one, I would know the other one, but I have to work out one of them. They're going to be the same. So this one is where x equals 1 in this, right? This is where x equals 1. And at that point, the function or the y value becomes 3 plus 5 times 1, right here, minus 1 squared. So this becomes 8 minus 1, that is 7. 8 minus 1 is 7. So this value is 7. And because of the symmetry of the values, this value is also 7. You understand? Good. And I will tell the examiner, I'm leaving these, my line of symmetry. All right? Line of symmetry. This is my line of symmetry right here. All right. So they can't penalize you for having advanced knowledge, guys. All right. All right. I'm going to tell him that this is my line of symmetry right here. So it means that my y values are symmetrical from that line outwards. All right. All right. So I don't need to calculate everything. All right. Next part wants us to draw the graph. Put in the other points and draw the graph. All right. Let's put them in. Let's put them in red and then draw the graph. So remember, sit here between these two marks at the 9 and the 9. This is the line of symmetry between them. Remember, it went up to 9.25 on this line. So your axis is going to be on this line. That's the axis. So your vertex is going to be on this line. We need to see where 9.25 is for the maximum point. You can't draw the graph and cut across here. So it's a maximum. It has a turning point like that. So anybody who draw and just come across here, it's wrong. You must know that a quadratic graph has a maximum vertex point. It's at 9.25. So right here says 9, This is 9. Right here says 9. So we're 9.25. Let's look at the scale. Let's look at the scale and estimate it. So right here is 9. This is 9.2, 9.4, 9.6, and 9.8. Good? So right here is 9.2. This is 9.2. We're going above that. And this is 9.4, don't it? So it means that right halfway here will be 9.3, don't it? So 9.25 is like right around here. It's 9.25 if you want to be accurate. But understand that? So we want to be right around here, like the bottom half or the bottom quarter of that range. We're coming right here. So right here is our vertex point. Right here. So when we draw the graph, we're coming right up to there. All right? That's our maximum point. All right, let's put in the other values now, though. The other values, the one that correspond to the 5 is 5. It's not a 5. Oh, this is a 3. This correspond to the 3 was 0, right? 0. And then 1 was 7. All right. So it's 3 then 7. So on the y-axis was 3 right here. That corresponds to that point. Then 7. All right. 1 took us up to 7 right here. Which is here. This is 7. That's the next point. Remember though that across here, 1 took us up to 7. And then 4 was also 7. See there, 4 was also 7, right? 4 was 7. So that's it. 4 took us up to 0.7. See there. At x equals 4, going up to 7. Right here. And then now 6 was negative 3. See there. 6 is negative 3. A point you have to put in as well. 6 corresponds to this line, down to negative 3. 6 is negative 3, which is down here. So those are your points. All right, put down this value here in blue, the 7th. Right here is 7. All right, and so you draw a graph through those red marks. Remember, your maximum point is right up here, guys. That's the maximum point right there. So you're going to draw the curve through those now. A smooth curve. All right, so I'm going to do it like this. Come down here, come down here, come down there, and go down to there. 1/2 of it, that's 1/2. The other half is going to come down here, come through here, go down there, and then go down to there. I'm going to do it like that. And that's my graph. I'm going to leave it like that. All right, what else do I want us to do? After we draw the graph down here, say, on the graph below, complete the graph, right? After we complete the graph, it says, write down the equation of the axis of symmetry. We worked out already. It is x equals 2.5. That's a vertical line right through here. Vertical line through here. See, it passed through between halfway between 2 and 3 is 2.5. X equals 2.5 is the axis of symmetry, that line. And let's try it better. Let's say we must just write it. I never asked us for it. So let's just write it down. X equals 2.5. Then state the maximum value, not the maximum point. The maximum value is the highest y value. We worked it out. It was 9.25. It is a yt value. 9.25. 1 mark for it. The maximum y value at the turning point up here. 9.25 that we worked out. A lot of people are going to put 9 in. Remember, the maximum value cannot occur twice at two places. The maximum value is at a single point only, at the vertex. I know the question did not ask us for the maximum point. They asked us for the maximum value. The maximum value is the highest y value, which is a y value at the turning point, the vertex point. All right, so it is a 9.25 that we calculated. What else I want us to do? Let's say, write down the coordinates of the point where this line crosses the x-axis. Now remember, on the x-axis, the y value is going to be 0. On the x-axis, the y value is 0. So the y value is 0 on this line. It means that this thing equals 0. So at that point, the 3 minus half x equals 0. And solving that for x, right? So multiply 2 by 2, we're going to get 6 minus x equals 0. So you're going to get x equals 6. If we do a little calculation quick. So x equals 6. So it means that that point, you say right on the coordinates of the point, is going to be 6 is the x value and 0 is the y value. 6, 0. This is the answer for that question. Then they also want the point where this graph crosses the y-axis. On the y-axis now, x equals 0. You put x equals 0 here, you're going to get y equals 3. So this one easy. The y value is just 3. So this point is where the x value is 0. Let's put over here. So the x value is 0 and the y value is 3. So this is the point again in red that I'm talking about. All right, 0, 3. Then it says now, on page 22, must draw that line. So this line that we just mark out, 6, 0 on the x-axis, 0, 3 on the y-axis. So that's why they ask us for these points, you know, because these points will help us to draw this line. So we pass through 6, 0, and 0, 3. So I'm going to go on the graph now and put in 6, 0, and 0, 3. Let's put it in blue. So 6, 0 is out here, right here. So 6, 0 out here, and 0, 3 is right here. Right here is 0, 3 now, right here. Right, same point to the graph crosses the x-axis, the y-axis. So we need a straight line passing through those 2 points. Straight line through those 2 points. So can get some other points. Rise -1, run 2. Or the gradient is -0.5. Rise -1, run 2. No, them not right. This is 3 -1 over 2. Okay. This is 2. All right. So remember the gradient is -0.5. Because I can't draw a straight line with this device, I just want to get some other points, right? And that's will be the straight line. Use the ruler and draw the straight line through them like that. But I want to get a little bit more accurate. So remember the gradient is -1 over 2. Means rise -1, run 2 to get other points. So rise -1, run 2 out to here. That's 2, 1, 2 units. So that's another point on the graph, on that line. Then rise -1, run 2 out to here. That's another point. Then rise -1, run 2. So you see all those points line up. So the line that you're drawing pass through these as well. All you would need on the exam is these now, if you have a ruler. Because I don't have a ruler, I'm doing this, right? So I'm going to go like this. So that is a line. I want to label it. Y equals x. What is it again? 3 minus half x. 3 minus half x is this line. All right. I'm going to show in the gradient a little bit here that we could have used to draw other points, put other points on the line. And then naturally, they're going to ask us for these 2 points with the line and the curve meet. They must ask you that. When you pass papers, you will know that. They're going to ask us for these 2 points. So right here is where x equals 0 and y equals 3. And right here, let's see if we can estimate it. Right here, where the line and the curve meet, at this point right here, looks like x equals, this is 1 now. This is 4, 4.1, 2, 3, 4, 4.5, and so on. So every line is 0.1. This looks like 5.5, 5.6. This looks like where x equals 5.6 right here. That looks like where x equals 5.6. The next question, I'm sure these are going to be your answers. But the question I'd like to ask is something about where they meet. The line and the curve meet. That is 5.6. Let's see. Sit here. Sit here. Use your graph to determine the solution. Solution is where they meet. So we need the y values as well. So based on the graph, these 2 lines meet at, we know 1 point already, on the y-axis was 0, 3. The other point, we know the x value is 5.6, but I didn't check the y value. So let's go and check the y value, where they meet. That looks like just, I wonder if it's on the x-axis though. No, but this is on the x-axis, it's not on the x-axis. Let's say it is right on this line. That is what? That will be 0.1, 0.1, 0.1, 0.2, 3, 4. No, that's not right. This is 0.1. No, this right now. This is a 1. This is 1. That's a 1. Then this is 0.2, 0.4, 0.6, 0.8. So this is 0.2 right here. 0.2. Just make sure I always check that scale properly. 0.2. So I'm going to say that the meet right here. So this is 0.2. Let's look at it. This is 0.2. Look like the meet halfway between 0.1 and 0 and 0.1. I'm going to say this is 0.1. 0.1. I'm going to put 5. I'm going to put the y value there as 0.1. The y value there is 0.1. It's not 0 because the point on x-axis is that. So don't meet on x-axis, you cannot put 0. I'm going to put 0.1 just above the x-axis, yes. 0.1. So I'm going to put 5.6, 0.1. And I won't bother waste time to check it. I'm just going to accept that for now and go. We're running late. 0.1. That's it. 2 more questions to go. Let's go. Number 9. Circular measures. Circle theory, sorry. Circle theory. Diagram below shows a circle with points P, Q, and R. P, Q, R, and S line on circumference of a circle. Center is marked O. So we have the line passing to the center. So diameter subtends 90 degrees, remember. It says PR is a diameter to the circle. AB is a tangent out here to the circle at the point P. It says angle APQ is 3x. That's right here is 3x. QPR is 2x right here. QPR. RPS is x. That's here. And the angle QSP is 54 up here. All right, let's go. First question says, determine the value of each of the following angles. Show detailed working range and give a reason. First angle I want is x. How can we get x? 1 million ways to get x. Look here. You can say the angle between this tangent and this radius is 90 degrees. And it equals 5x. So 5x is 90 degrees, don't it? So we can say 5x equals 90 degrees. So 90 divided by 5 is how much? 18. 18 degrees. That's right? Don't it? 18. That's one way to do it. Another way to do it, guys, is to say, watch this now. Angle between this tangent and this chord is 3x. So it means that this chord is subtending the same 3x at the circumference out here. So it means that this 3x is equal to 54. So 3x equals 54 another way. So again, x equals 18. So whichever method you prefer. Understand? I'm going to use the first one. Tangent and radius. I'm going to use the first one. So I'm going to tell him that the angle here between here and here is 90 degrees. Tangent and radius rule. Let's write it. So I'm going to write it this way. I'm going to say angle APO is 90 degrees. Angle APO is 90 degrees. Reason? Angle between tangent and radius. But at 90 degrees, that angle is 5x. 3x plus 2x is 5x. So 5x equals 90 degrees. And it's x degrees, 5x degrees. And so x degrees is 18 degrees. Therefore, the value of x is 18. And I have my reason right here. So I don't have to write it up there. So that is it. One can write this back on this line. But if you put it on the paper there, you have to give you a mark still. Once the answer is on the paper, they have to give you your marks. So the x is 18. All right? Let's go test the one. The one, the angle y. Let's look at the diagram for angle y now. Angle y. All right. What that mean, angle y now? So angle y is inside this triangle, which is a right angle triangle. Why is that a right angle triangle? Because we have an angle subtended by the diameter over here. So it means that over here is 90. So it means that this x and this y also add up to 90. because that triangle there is a right angle triangle. So x plus y is 90. So y is going to be 90 minus x. That's one way to do it. I'm going to use that. All right. So I'm going to tell him first that this angle is 90 degrees. So them two here must add up to 90 in the triangle. So which angle is this? Angle PSR is 90 degrees. Angle subtended by a diameter. So then for this one, I'm going to say angle PSR equals 90 degrees. Why? Angle subtended by a diameter. Therefore, the y is equal to 90 degrees, or the y is equal to 90 minus x in that triangle, which is 90 minus 18. How much is that? 72? 72? Which is 72. Why is that? Because total angle in that triangle is 180 degrees. Because total angle in triangle, which triangle we're talking about? This triangle right here, RSP. Total angle in triangle, RSP, is 180 degrees. And we already have one of them equal 90. So the other two must add up to 90. And so the y is 72. I'm not putting the degree on it because the question gave us y degrees. So the angle is, the value of y is just 72. Then the one z, let's look at it now, z. So z and y equal now. Why? Because the two of them subtended by this chord. See, the z is subtended by this chord. Let me draw out the chord in blue. The z is subtended by that blue chord. The same blue chord is subtending the y angle up here. Same segment too. So these two angles are the same. So the z equals y. Same segment rule. So we can write that. The z is equal to y, which is, what was y again? 72 degrees. 72. 72. We're not going to put a degree on it because the question said 0 degrees. Angles in the same segment are equal. Angles in the same segment are equal. That's the reason. Angles in the same segment are equal. That done. Then we'll come to this bearings question. Question said, diagram below shows a straight road connecting, it shows straight roads connecting L, M, N, and R. It says LR is 18 kilometers down here, LN is 12 kilometers there, MN is 10 kilometers. These are all roads. Angle RLN is 25 degrees, sound like a nice SBA topic. Get some roads and get some bearings and all these things. Angle LMN is 88 degrees inside here, 88 degrees. Question says, calculate the angle MLN. That angle MLN is this angle inside here, this one. So this question is asking us for this angle. So we're going to come and work in this triangle. Let's look at it now. We're working in this triangle. It is not a right angle triangle. So we can't use so-called tower. We can't use Pythagoras theorem. We can only use the sine rule or the cosine rule. This time we can use the sine rule because we have this pair. Angle and side opposite each other. We know both of them. To find this angle, we're going to use it with this pair to find this angle. So using those as our pairs, opposite each other. So let's write it out. Let's call this angle theta on the diagram. Let's call it alpha on the diagram and reference it down here. So we're going to call this angle alpha right here. I'm going to be using sine rule. to get it. So it's going to be that sine alpha over the side opposite, sine of alpha over the 10 opposite to it equals sine of the angle that we know, which is 88 degrees, over the side opposite the 88 is 12. And then we're trying to make alpha the subject. So same thing again. Multiply the 10 first, and then take the inverse sign. So we can say alpha equals sine to the minus 1 of, the 10 is up here, so you get 10 sine of 88 degrees divided by the 12. And you just put everything in the calculator one time. Notice that don't give you a lot of space to work. So that shows that you have to be very efficient with the calculations. Everybody got it? How much in it? 56? All right, let me try now. Sine to the minus 1 of a fraction. 10 sine 88 over 12. 56 degrees. Beautiful. 56.4. 56.4. They didn't tell us the accuracy, so give it to 3 significant figures, or in case of degrees, 1 decimal place. 56.4 degrees. All right, that is that. So that angle is 56.4. Then I want the length NR, the distance NR. That's this distance. So for that one now, we're going to work in this triangle. And now in that triangle, we have a classic case for the cosine rule. 2 sides and an angle between. Cosine rule. Remember, cosine rule starts out like Pythagoras' theorem. So you're going to start out as if you were trying to find an hypotenuse. So we can just write one expression. So we have to be writing a lot. So NR is going to be equal to the square root. Start like Pythagoras' theorem. Huh? Oh. Yeah, man, let me show one. All right. You join anything online later? All right. So good. So start like Pythagoras' theorem. 12 squared, 18 squared. 12 squared, 18 squared, like Pythagoras' theorem to begin. Then subtract a piece. So subtract 2 times the 12 times the 18 times the cosine of the angle between the 12 and the 18, that's 25 degrees. And I say, the question don't give you a lot of space to work with. That is proof that they don't expect you to do no work but calculations. They wanted to get your answer quick and fast. Just put all of this in the calculator one time. How much? All right, I'll work it out now. So it becomes the square root of 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 25. 8.7. I'm going to put 8.75, 3 significant figures. I'm going to write NR equals 8.75, what is it, kilometers. Put 8.7, they give it a mark. Well, let's put 3 significant figures. 8.75 kilometers. All right, that's that. Next thing, determine the bearing of tone R from tone L. Let's make a note from where we want it. Always note the from position. So it's from L to R. So the bearing must be done at L. Let's look at the diagram and see what angle that is and draw it on the diagram. From L to R. All right, let's go back up here now. We're going from L down to R. So we want the bearing down to here. So this is the from position. They have the north line there. So the angle that you want is a clockwise angle all the way down to the line out to R. So that red angle is the angle that I want. If you call it theta, you realize it becomes the sum of the 50, the alpha, and the 25. So the theta angle becomes 50 plus alpha plus 25. I already know the alpha. What is the alpha again? 56.4. All right. So because we're going to give the answer to 3 digits, whole number, and these are already whole numbers, we can just put the 56 for the alpha. All right. So let's write it down here now. So this angle bearing, we're going to call it theta, and leave the theta on the diagram for them to see. All right. Did I call it theta? Yes. I'm going to say that angle theta is the 50 degrees plus the alpha plus the 25. So it's 50 degrees plus 56.4 degrees plus 25 degrees. And the answer works out to be 50 plus 56.4 plus at times plus 25. 131.4 degrees, but because it's bearings, we're going to approximate that to 131 degrees and leave that as our answer. Question done. One last one. It's just 2. You want to take about 10 minutes and finish this last one. And then we're going to break until it's 4 o'clock. We're going to do vectors and transformation. All right? At 4 o'clock. All right, let's go. Vectors. This question says 3 points O, P, and R are shown on the grid below. O, P, and R. So we have those coordinates. Let's write them down out here. So O is the origin. P is the point -2, 4. Let's write it. P is the point. P is the point -2, 4. And R is the point 5, 1. R is the point 5, 1. Remember, the position vector will carry the same values as the coordinates. All right? Question says, write down the position vector of R, OR. So because these are the coordinates, the position vector OR will have the same values, 5, 1, as the coordinates. All right? And we can write the OP as well, but we don't need it yet. Next question says, another point Q is located such that QR, which means from Q to R, is this vector. It means to go from Q to R, you go 2 to the right and 7 down. That's what it means, you know. But look here now, they want us to locate Q. And it is R that we have on the diagram. I'll do the mathematics the easy way. What we're going to do is reverse this direction and go from R to Q instead and reverse the vector. So if QR is this, it means that if QR is this, it means that RQ becomes -2, 4. So to go from R to Q, we go 2 to the left and 4 up. And that's how we can locate Q. Use a diagram to help us. This means 2 to the left, 4 up. So it's like this. It's like we're at R, and we want to go Q, go 2 to the left, this way, and 4 up. That is where the Q will be located on the diagram. All right. Let's do it. So starting at R, we're going to go 2 to the left. See here? 1, 2, 4 up. 1, 2, 3, 4. So it means that Q is right here. Do the mathematics the easy way. So Q is a point 3, 5. So the position vector of Q is 3, 5. Right? Question say, to locate the point Q on the graph. So we have found it on the graph. That's where it is. Them say locate it. So we have located it on the graph. That Q, it is right here. Because look at it, you know. They said to go from Q to R. This means, sorry, this vector means from Q to R, you go 2 to the right and 4 down. excuse. So see there, it's proven. It's proven. To go from this Q that we have found to this R, 2 to the right and 4 down. So what we did, use our brains, and because we know R, we reverse this vector. We reverse this vector that they gave us. So instead of trying to go from Q to R, we say, okay, since you know where R is, let's reverse the vector and go from R to Q instead, and go the opposite direction. And all we did was put the negative on those values, but we're going in the opposite direction. Simple as that. And so we did this on the diagram to locate the point Q. 2 to the left, 4 up. Simple as that. All right. Next question. What is the modulus of QR? Easy. Remember, QR now has these values in them. So it's almost like you want to find this length. I know that this dimension is 2 and this dimension is 4. So that length using Pythagoras' theorem becomes the square root of 2 squared plus 4 squared, which basically is the same value that's in the vector that you would use. Don't matter. Right? The modulus of QR is the square root of 2 squared plus 4 squared. That is it. All right. Now this is 4 and 16. That's 20. I'm just going to write the square root of 20 units. So you don't have to work it out. You can leave it like that. Square root of 20 units. That will reduce to 2 root 5. Because the 20 is the same as 4 times 5. If you square root the 4 times 5, the square root of the 4 is 2. So it becomes 2 times square root of 5. So you could have put 2 times square root of 5 instead. But if you leave a square root of 20, that's all right. If you even work it out and put a decimal, you give it the marks just to see. Next part. Show by calculation that OPQR is a parallelogram. Remember, parallelogram has 2 pairs of equal opposite sides in vectors. 2 pairs of equal opposite vectors. So we need to identify which opposite sides we're going to show are equal vectors. All right? OPQR. Let's look at it now. So let's draw it on the diagram. So this is it. Now what do we know? We already know this vector, right? QR, right? In fact, we know this vector, RQ. So we're going to use that one. So we know the vector from R to Q already. It has to be equal to OP. That's why I know what must happen for it to be a parallelogram. So we know that RQ has to be equal to OP. And then the other pair must also be equal. So this PQ across here has to be equal to OR. So PQ has to be equal to the vector OR. So these are the things that we need to show that is a parallelogram. So let's copy it down and tell them that. Copy it down and tell the examiner that's what we need to show. To show that is a parallelogram, that's what we need to show. We need to show this. That's right. Need to show this. Teacher, need to show these 2 things. Now I think we have this pair already, you know. Remember, the RQ is in purple. The RQ, remember, we had reversed it. The RQ, we had gotten it to be minus 2, 4. And we did say that P is a point minus 2, 4. So that OP is minus 2, 4. I'm going to actually write it here to make sure it's on the document. OP is minus 2, 4. Make sure we have it on the paper somewhere. So I'm going to say that we have that already. RQ is already equal to OP minus 2, 4. So we show this one already. We need to show this one now, in which we have the OR. Remember the OR, we have it already. It is 5, 1. We need to calculate now the RQ and show that it is 5, 1. The PQ, I mean. So we're going to say, and PQ, remember now, it is OQ minus OP. O time the last minus O time the first, which is the OQ. Since Q is this point, what was Q again on the diagram? Q was this point, 3, 5. Let's write it here as well. The vector, put on the page somewhere. OQ is the vector 3, 5. So it is 3, 5. 3, 5. OQ is 3, 5 minus, what was OP again? No, not OP. OP was what again? OP was minus 2, 4. Minus 2, 4. Yes, here OP is so minus 2, 4. And if you work this out, what it becomes? This one is give me 5. Minus is a plus. I get 5. And then 5 minus 4 is 1. And this 5, 1 is actually OR. So I've now also shown that PQ is equal to OR. So I've shown this as well. I put it on paper and I need to show those. And I did show them. So I can draw the conclusion. Let's make this a little smaller. Draw the conclusion now. And say, back in blue. Therefore, OPQR is in fact a parallelogram. So to show that's a parallelogram in vectors, you have to show that the opposite sides are equal vectors. Because when they are equal vectors, they are parallel and equal in length. That's why you have to show that it's a parallelogram. Down here now. It says calculate the value of x. Calculate the value of x and y. So which these two equal that. That's multiplication, equality of matrices. So remember, to get this vector over here, you would multiply the rows of the first matrix and the columns of the second matrix. Let's do them one at a time. This x value will be equal to this row times this column. So we can set that up, right? So the x value would have been equal to this row 1, 5 times this column negative 4, 2. And that would work out to first element times first element, which is negative 4. Second element times second element, which is 10. This equals 6. So x is 6. And then now, this 6 right here would have been this row times this column. All right, so we can set up that as well. So, and do it the other way. This row times this column will be equal to 6. So we can say, okay, to get the y, the 2y row times the minus 4, 2 column is equal to the 6 out here. So how would this work now? This value times this value, that's negative 8. First element times first element is negative 8. Second element times second element, y times 2 is 2y. That is equal to 6. Transpose this 8, we get 14. Divided by 2, you get y equals 7. So our answers over here are x equals 6 and y equals 7. Anybody got that? Huh? You get it? All right. Last part now. Easy question. Transformation T represents a matrix this. Everybody must know that that is a y equals x reflection matrix. More things you know, the better. It maps this point onto this point. Why bother with all of that when you can just know the matrix and done? Describe the single matrix T. Better just know it and done. You don't have to go figure it out. It's only 1 mark, 2. Well, 2 marks for it. The reflection in the line y equals x. And you're done. So better just know the matrix and done rather than to go have to figure it out in the exam. So T is a reflection in the line y equals x. And you're done. Now, people who don't know that might have to make a sketch and all these things to do that. But if you know that reflection line y equals x reverses the coordinates, then maybe you could know. You have to go in the exam armed with the knowledge of things that they will ask you. You don't make no sense to go in the exam to figure out stuff that you know that the possibility they will ask you. Arm yourself with the knowledge of things that they will ask you. They're not going to ask you everything, you know, but you need to know everything that you need to know. I don't know what's coming on the exam. So you can get these 2 marks easily by just knowing that matrix. That's why I said learn the matrices. All right, it's now 2:20. All right. Students online, they good?
Yes,
But okay? All right, we're going to break now. And then we're going to pick up back. Let me know your marks, please. I want to know your marks. Remember, it's 70%. People online, who did this paper? Online. 100. People mark out at 100. Anybody online can tell me what they got? Huh? I'm not hearing.
Sir, I got 80%.
All right. Now, what you said?
I got 80%.
87?
Yeah,
No,
80, not 87, 80. Yeah.
All right, good.
Yeah, I got
Next
70.
week you have to reach 85 at least. Good. Yeah, next week already. So you guys at next week target already. Good. Very good. That next week target already, that's good. Anybody else? Justin did this paper. Troy, Zachary. Who else did this paper? This was a nice paper, and this paper had some nice questions on it, believe me. If you get 85 on this paper, you're good. You're going on good. That's why I say 70 is all right now. Anybody else? With 2 weeks to go, 70 is fine. Because I should be improving significantly between now and next week and the exam. All right, I don't hear anybody else online say anything. So I'm going to end the session now. Remember, we have the marathon session starting at 4. We're going to do vectors and transformation starting at 4 o'clock. All right, bye guys, later. Bye everybody. When everybody has some vectors and some transformation at 4 o'clock. Or 2 hours of vectors and 2 hours of transformation. All right, bye. Later.
All right, bye, sir.